In a mid-sized manufacturing company, automation has expanded across procurement, production scheduling, quality control, and demand forecasting. At the consolidated level, operating expenses have declined, yet internal budgeting has grown more contentious, not less. Department heads now spend more time disputing shared cost allocations than they once spent approving the initial investment. Procurement reports labor savings but challenges rising compute charges. Production reduces overtime yet resists absorbing data pipeline costs. Finance teams find reconciliation itself becoming a recurring workload. This raises a precise economic question. If AI compresses costs and improves visibility, why does it frequently turn departmental budgeting into a persistent exercise in contested allocation? The prevailing assumption is straightforward. As decisions move to models, costs should become more traceable, usage mapping cleanly to usage, shared systems distributing proportionally. Under this view, transparency should simplify attribution. In practice, the opposite dynamic often emerges. AI introduces a class of shared economic resources whose costs resist clean division across organizational boundaries. At the center lies the structure of the new cost pool. Model hosting, inference capacity, data pipelines, and periodic retraining are provisioned centrally but consumed unevenly. These resources are sized not to average departmental demand, but to collective peaks. A surge in one function, month-end forecasting, for example, draws against capacity reserved for the entire system. The incremental usage appears localized. The capacity it relies on is not. The cost is shared. The trigger is not. A simple relationship sketch makes the shift clear. Before AI, departmental costs appear as separate vertical stacks: labor, licenses, equipment, largely attributable one-to-one. After AI, those stacks compress, but a horizontal layer emerges across them: shared infrastructure. This layer must be divided downward: allocation keys, query volume, data throughput, process frequency, headcount, attempt to distribute the cost. Each method approximates usage. None captures true economic causation. The reported cost structure changes depending on the chosen key, while no department controls the size of the shared layer itself. This is where incentives begin to shift. A department increasing model usage may reduce its visible labor cost, while simultaneously increasing its allocated overhead. Another may limit usage to protect its reported numbers, effectively subsidizing heavier users elsewhere. Optimization moves from process efficiency toward allocation positioning. The improvement appears real. The attribution does not remain stable. The first clarification follows directly. What appears variable at the enterprise level, compute consumed on demand, often behaves closer to fixed cost once allocation rules lock in. Capacity must be provisioned for peak conditions across the organization. Allocation then distributes that committed cost regardless of momentary usage. The cost appears flexible in theory. It becomes structurally committed in practice. Usage-based allocation introduces volatility that complicates forecasting. Fixed share allocations stabilizes reporting but weakens incentives to constrain consumption. Neither approach fully aligns reported cost with underlying economic cause. Even when allocation feels settled, a second layer surfaces in timing. Model retraining, security updates, and drift correction occur irregularly. These costs rarely align with any single department's activity cycle, yet they must still be assigned. Finance, therefore, faces a recurring trade-off. Smoothing these charges reduces volatility but obscures visibility. Passing them through immediately preserves transparency, but creates lumpy departmental results. In both cases, the collective nature of the benefit becomes fragmented through the mechanics of allocation. Maintenance follows the same pattern. Versioning, compliance adjustments, and system updates are required for all users, yet attributable to none with precision. The benefit is shared. The accounting is forced. Here, the economics compress. AI removes direct, visible cost from departments, labor hours, error remediation, decision latency, but it replaces them with a shared layer no department fully controls. The savings are real. They are no longer cleanly owned. The advantage holds only while the shared layer remains proportionally small relative to the savings it replaces, and while the allocation process itself remains lightweight. Both conditions tend to narrow over time. A third clarification emerges around capital commitment and decision rights. Once costs are allocated, the platform is treated less as a discretionary service and more as embedded infrastructure. Departments experience their portion as fixed overhead rather than variable spend. Requests for expansion, additional capacity, or new capabilities shift upward into enterprise-level capital decisions. Benefits remain distributed. Costs feel immediate at the departmental level. This creates a quiet misalignment. Organizations may become simultaneously over-provisioned for current usage patterns and underinvested in system evolution that would improve overall efficiency. The constraint is not technical, it is allocative. When external vendor contracts enter the picture, the pattern intensifies. Agreements negotiated at enterprise scale often fix a baseline cost, independent of marginal departmental usage. What appears variable in aggregate becomes semi-fixed when divided internally. Departments reduce usage. Allocated cost does not fall proportionally. The cost behaves differently depending on where it is observed. These allocation challenges do not eliminate cost compression. They determine whether that compression translates into durable enterprise improvement or reappears as internal friction and distorted incentives. In observed practice, the departments reporting the most favorable post-AI cost outcomes are often not those achieving the largest operational gains, but those best aligned with the allocation mechanism itself. Operational efficiency and reported efficiency quietly diverge. Returning to the earlier relationship sketch, the horizontal layer of shared infrastructure persists. Its scale can be managed through capacity discipline and governance, but it cannot be eliminated without removing the underlying automation. Allocation is not a temporary phase. It is a structural condition. AI does not dissolve departmental cost boundaries. It redraws them as interdependent, negotiated, and continuously adjusted. The capital reality lies in how these shared layers quietly redraw the boundary between what departments can still control and what has become inherently collective.